Let's apply some of our new symbols and some of our new formulas to an actual problem. So in this question, we've got a student's iTunes library having a very large number of songs. So I don't even know how many songs they have in their library, but they have a ton of songs. It says the mean length of the songs is 243 seconds and the standard deviation is 93 seconds. The distribution of the song lengths is right skewed. Using his digital music player, the student will create a playlist that consists of 25 random songs. So we are going to take a sample of 25. So that's going to be our in value. And we've got our standard deviation, it says up here, so that's our sigma value. Our first question down here, I guess we can label this. If we label this number, we're actually answering part B. So part B says, is the mean value of 243 seconds an example of a parameter or a statistic? So what does this 243 seconds go with? The mean length of the songs. Well, it's all of the songs, right? The end of the entire library. So this would be my mu value. That's the mean of all of them, not the mean of the sample. So if it's the mean of the or the mean of the population, that is a parameter. Okay, let's circle back to part A. What is the population and what is the sample? Well, I think we sort of have already answered that as well. The population is all of the songs. And the sample is the 25 that were chosen. That's the in value. And we don't know big in this case. I don't know how many songs he has on his player, but a lot apparently. Okay, when they take this 25 sample, it says, what should the student expect the average song length to be for his playlist? So that's where we go back to what we talked about in the video number 1, where the mean of your sample means should be the same as your population mean. So if he takes a sample, we expect that average to be the same as the overall average. So since the overall average was 243 seconds, then the average of my sample should also be 243 seconds. So what do we expect? We expect the average, or we expect the mean. So I would still expect it to be 243 seconds. What is the standard error for the mean song length of the 25 randomly selected songs? So we expect the mean to be exactly the same. The standard deviation is going to change though. When I take a sample, depending on the sample size, I'm going to get a new standard error. So this is where we need that new formula. The standard error, we know what the standard error is for the whole population of songs, but what would be the standard error of the 25 playlist? We'll have to calculate that by doing the standard deviation over the square root of the sample size. So I use that 93 seconds here over the square root of 25, which is 93 over 5, which is approximately 18.6 seconds. So that's that plus minus amount of the sample. So it's really brought it in quite a bit. The plus minus amount for all of his songs was 93 seconds, plus 93 or minus 93 from the 243 average. So there's a wide variety, right, of songs. He's got really, really long songs, some very, very short, very wide standard deviation. But if we take a sample of 25, we expect that standard error to kind of get sucked in and get closer, like bunched in around that mean by quite a lot more. This should say, what is the standard error for the mean song length if the sample is increased to 50 songs? So what if he did a 50 song playlist? What will the standard error be then? Well, let's just change our formula. It's still going to be 93, but now over the square root of 50. And if I use my calculator on that, I should get about 13.2 seconds. So notice what happened. As the sample size gets larger, so as the sample size increases, the standard error decreases. So that is a common thread. That's the same as what we talked about in chapters 7 and 8. The bigger samples we take, the smaller margin of error we expect.